Page 329. Alright, so we are going to look at exponential graphs and asymptotes. And our learning targets today determine when an exponential function is increasing or decreasing, describe the end behavior of exponential functions, and identify asymptotes of exponential functions. So kind of looking at the first two, to determine when an exponential function is increasing or decreasing, any graph, we always read from left to right, correct? Just like English, left to right. So if it's increasing, as it's heading right, which way is it going? Left. Right. If it's going this way, it has two directions to move, right? It's going this way. It can move up or down. So if it's increasing, it's heading which direction? As I'm moving this way, if I'm increasing, which way am I going? I'm going right, but if I'm increasing, I'm going up. So I'm going up and to the right that way. And if it's decreasing, then it's down to the right. So graphs only move to the right. So, is that your left? What's that? Yeah, that's what I mean. It's my right. All right, let's go this way. So as it moves.
Well, you were right. Oh, you were right.
Oh, okay. No, it's right. Yeah, this is right.
Savannah's.
No, that's what I'm getting. No. So as we're going this way to your right, it's going up, going down. It's I confuse my left and right. So well, I was confused. All right. So it's either increasing or decreasing. So as we're moving to the left or to the right, you're either going to positive infinity if it's increasing, or to negative infinity if it's decreasing. All right, end behavior. How does that relate to the increasing or decreasing part? As a function is moving to the right, because it's always moving to the right. If it's increasing, what's the end behavior doing? It's pointing towards the sky, or what number? Positive infinity. And if it's decreasing, end behavior is pointing to negative. All right, so then we're also going to look at sometimes, so that would be for growth. We also have some other, that's kind of like based on what we've learned so far. And then we're going to learn like one other little thing that's special about exponential functions. All right, so we're going to graph. So I guess we'll just do Desmos together. So we're going to graph these. All right, so where's this graph going? What's going in? Is this one increasing or decreasing?
Increasing.
It's increasing, right? Because as we move to the right, it's pointing to positive infinity. So what's the end? What would we say about the end behavior? So as x goes to positive infinity, as we move right, our end behavior, our y, is going towards positive infinity. We can change this if we do just by putting a little negative. All right, so now what's happening?
Decreasing.
All right, so as we head to the right, what's our graph doing?
Decreasing.
And it's going towards, it's decreasing, and it's going to negative infinity. So is this a growth or decay? Wait, all right, so what tells us? So if we're looking for growth or decay, we're looking at this. And so that's positive, right? It's greater than 1. So if it's greater than 1, is that decay or growth? Growth. Now this one's negative, right? So this would be a negative growth, and that would be something that a real world application of that would be like credit card debt. If you never pay it off, if you just let your balance grow, it's going to grow exponentially because it's you have your interest rate that's being applied each month, but it's money that you owe, and so um, that would be like bad credit card debt. And then our other one, we had so this one, is this growth or decay? Decay. So now as we're heading to the right, this one is the something new. So as x is heading to positive infinity, what number are we heading to? All right, but is it ever going to cross that? No. So it's going to approach 0. So this one, y is going towards 0. So with decay, that's where our trick is going. So with growth, that's kind of similar to the ones that we've looked at, but now this one, it's like a Trump wall at our x-axis. our exponential function is heading towards it, but it's not going to cross it. All right, so looking at this, what was our domain? X was going towards, x was approaching what? Positive infinity. But then what was happening on the left side? Did we have a, where was that one going? Negative infinity. So x is between negative, so we have all real numbers essentially, so we can plug in anything in for x. So that's going to be anything from negative infinity to positive infinity. But what about our range for this one? So this is when we were above. So our graph looked like that. No, that's not what our graph looked like. Our graph looked like that. So for that one, what would be our range? All right, so, and what's your lowest point? What was the lowest point we were going to have? 0. So y is going to be everything greater than 0. So writing is. All right, so now consider this function. So this one had looked like that. So this one, what's our domain? So we're starting, our graph started at 0, right? And then it was everything to the right. Yeah, so we're going to say x is going to be everything greater than 0, or x is going to positive infinity. And then what about our range? All right, so our lowest point again was 0, and it was everything above. All right, so when we're looking at domain, we're looking at what are the x values that we can put in, and for the y, what are we getting out? All right, so for this one, for 6 times 1.2 to the x, was that an increasing or decreasing function? We can look at that again. All right, so for this one, what did we have? Is this increasing or decreasing? It's increasing. And then what about our other function? Are we paying attention?
Yeah.
And then this one. Is this one increasing or decreasing? I'm looking at this now. Is our domain starting at 0? No. Where's our domain starting? If we keep on going. I always forget that one doesn't work. So it's going towards positive infinity, but if we're looking at our domain, is there any value of x that we can't put in? Look, no. So let's go back and change that. Let's change this so we negative infinity to positive. Sometimes it's good to revisit your graph. And then this graph was an increasing or decreasing? It was decreasing. Let's erase my sketch because that wasn't right. Alright, so as you learned in a previous activity, the end behavior of a graph describes the y values of the function as x increases without bound and as x decreases without bound. If the end behavior approaches some constant a, then the graph of the function has a horizontal asymptote at y equals a. When x increases without bound, the values of x approaching positive infinity. When x decreases without bound, the values of x approach negative infinity. So describe the end behavior of each function as x approaches infinity. Write the equation for any horizontal asymptotes. All right, so let's look at this. So looking at the blue equation. Zooming in. All right, so this one, as x approaches positive infinity, as we're heading this way, we said we're increasing. As x approaches positive infinity, what's our y? What's the right end approaching? Y approaches positive infinity. Now let's look at the left end behavior. All right, so here as x approaches negative infinity, where's our graph going? To 0, right? We have a trump wall. So a trump wall is a horizontal asymptote, and so that's it's a horizontal asymptote. So it's all right. So an asymptote is essentially a trump wall. You put it up, and things can't cross it, right?
What if they do cross it? You don't find a way.
It's electrified, high voltage, like Jurassic Park type thing.
They'll use the hold on.
So here, our graph is trying. It keeps walking along the fence, trying to find a weak spot. But the thing is it's not going to. There's no breaks in this. So there's the wall, and there's like a guy with a machine gun on top of it.
Whoa! What is?
It's a trump wall. So our graph, our function is coming along, and it's running along it, but it's not going to be able to get past. So it's approaching 0. And then where is this line at? What would be the equation for this line? It's horizontal. Y equals 0. All right, so now let's look at our other equation. So we have our decay. So now this one, looking at this, as we're heading to the right, as x goes to positive infinity, where's our function going? To what value? It's going to the trump wall, which is located, well, that our horizontal asymptote.
Just think of a donkey and then
Asymptote. All right. So where's our horizontal asymptote? Where's our horizontal asymptote at?
0.
At 0. So y equals 0. And that means that our y value is heading towards that trump wall, but it's trying to find a good x.
Wait, so technically the Trump wall has like a curve on the side of it.
Yep.
Yeah, that's California.
Yep. So this is like San Diego here.
Further than
Coming along.
it goes around.
All right. So then, as we're going to the left, where's our graph going?
Up.
It's going up to
95.
or positive infinity. So it's heading up, right? Is it ever going to stop? No.
It ain't never gonna stop.
Nope. It's heading towards Canada. All right. So we have a horizontal asymptote, and that's a trump wall for our graph. All right, so questions on this, on finding a horizontal, finding the asymptote for our...
Yeah, at least they got something out of it last week.
I know. Was able to bring her any Benson.
Yeah, it's not We're all
All right, so number 5, describe the end behavior of each function as x approaches negative infinity. Write the equation for any horizontal asymptotes. All right, so for 6 times 1.2 to the x, what's our horizontal asymptote? So describe the end behavior as we're heading towards negative. We already did this because we kind of did everything together. So as we're going to negative infinity, where's this graph going? So I can bring it up. So we have, as we're heading towards negative infinity, where's this graph going? So we're heading towards negative infinity, x equals negative infinity. So go this way, so we're heading towards our asymptote, which is located where? At 4, we got 0. Y equals 0. So we're looking at where it's crossing. So here we go, flat. Remember, horizontal lines are y equals. We'd be crossing the y-axis at 0 here. And then it's asking for the decay. So just to kind of look at that one again. So as we're heading towards negative infinity, where's this one going? Positive infinity, yep. As x heads to negative infinity, the y is heading towards positive infinity. All right, so identify any x or y intercepts for each function. So if we look at them, does this have any x-intercepts? Is it crossing the x-axis? No, because it's heading toward, because the asymptote's there, right? And it can't cross it, so it can't cross the x-axis. Where's the y-intercept at? So here at 0, 6. You're so close. That's a good estimate. All right, so looking here, where is the blue one? Where's that y-intercept at? Same spot, right? And if we substitute 0 in for x, anything to the 0 power is always 1 to the 0 power is always 1. So we have 6 times 1. So we're crossing the y-axis at 6. And then does this have an x-intercept at all? No. No. Trump wall. All right. All right. So number 7. Consider how the parameters a and b affect the graph in general exponential function f of x equals a times b to the x. In many parts, a to c, use a graphing calculator to graph each of the following functions, compare and contrast the graphs. All right, so let's look at a. So we have 2 to the x, and then we have 3 times 2 to the x, negative 3 times 2 to the x. So let's do those first. forgot. What was the next one? 3. All right, so looking at our 3 graphs. So what's different about them? All right, the green one's negative, so as we're heading to the right, that one's decreasing, right? The y-intercepts, we have 3 different y-intercepts. Okay, so they have like different like slopes. They're all increasing or decreasing at different amounts. So, I don't know, what's the question asking? Okay, number 7. Okay, so looking at this one, how does the red one differ from the blue one? Okay, so it's further to the right. And so they're kind of increasing at the same amount, but the red one's kind of just doing it a little further to the right, right? They have like the curve, kind of like they're equal distance the whole way up. It's doing it a little more positively. So, and then if you look at the equations, what's that 3 doing? So here we have a y-intercept at 1, and then here we have a y-intercept at 3. So the blue line is kind of all the same. The points are all the same. Like here, we're at 1, 2, and this one's at 1, 6. This point is at 2, 4. The blue line is at 2, 12. So what's happening to all of our points? They've multiplied by 4, 3. And so like all of the numbers, like the 2 to the x is going to be the same, but the blue line is multiplied by 3. So it's kind of increasing a little bit faster, 3 times faster. But then if we look at the blue line and the green line, what's a geometry word we could use to describe them? Opposite. That's a geometry word. They're opposite or reflections of each other. So, what do they all have in common? As they all have the same trumple, right? So as we head to the left, as x goes to negative infinity, they all have a horizontal asymptote at y equals 0. So if we look at that first term, that's affecting what part of our graph? The 3 and the 1, like this first term here, how are those affecting the graph? So how did we keep touching that? So this one we can say has like a 1 in front of it. So 1 times 2 to the x. Is that fair to say? What's the y-intercept of the red line? 1. What's the y-intercept of the blue line? 3. And how does that relate to the equation? It's that number that's in front, right? What's the y-intercept of the green line? Negative 3. How does that relate to the equation? That's that number right in front, correct? So the y-intercept is that number that's in front. It's that a value of the equation. Does that make sense? let's look at, so if I have the equation 1/4 times 2 to the x, what do you think the y-intercept's going to be? So what's that y-intercept there? 1/4. And if we do negative 1/4, how's that going to compare to that equation? So what do we notice about the purple line and the orange line? How do they compare to one another? The reflection. So it's the same numbers but opposite signs, right? So as we move to the right, they're going to be they're going to be equal distance apart, or equal distance from that asymptote. But these are going to be, this is +1, -1. Here is, whatever that is, +4, and then we'd have -4 down there. So same numbers, opposite signs. One's increasing, one's decreasing, and they're doing that at the same rate. All right, and then in part D, we have the generic form, the standard, like the equation formula for exponential functions. Where A is your y-intercept and B is how fast or you're increasing or decreasing. If B is greater than 1, do we have growth or decay?
Growth.
Growth. And if B is between 0 and 1, what do we have? Decay. If A is positive, are we increasing or decreasing? Increasing. So then if A is negative, we are decreasing. You guys have questions? Okay. All right, so then your homework is going to be number 11 through 15 at the bottom of the page. 15.